Graph the function. Now, if you watch all my videos in order, you saw a very similar video before this one, and we're going to treat it the exact same way. Now, before we were graphing functions, we were given a domain. We were given the x values to use. Now I'm not given x values, so I have to create my own x values. So I'm going to make myself a 3-column chart. In the first column, I'm going to pick a bunch of x values. In the second column, I'm going to say f of x equals 4x minus 4, and that's going to show me showing my work. And in the third column, I'm going to have the coordinates that I'm supposed to get after plugging stuff in. Okay. Now, I pick my x values. I pick them. Does it matter which x values to pick? No. Now, the x values that I pick, I have a feeling aren't going to be good ones, but that's okay. It's the thought that counts. In my last video, I picked -2, -1, 0, 1, and 2, and I'm going to do the exact same here. If while doing this, you realize that the points you picked are bad, then pick different points or pick more points. And if you're wondering, well, what do you mean bad points? Oh, you'll see, friends. You'll see. Now that I picked my x values, I'm going to plug them into f of x. So f of -2 means I'm going to write out 4x minus 4, but replace x with parentheses -2. So 4 times parentheses -2 minus 4 is following PEMDAS. 4 times -2 is -8 minus 4, and -8 minus 4 is -12. Now I'm going to step outside the box compared to what I did before. All right, now usually I do all the math, and then I put my points in. This guy says if I plug in -2, I get out -12. Great. There's a problem though. This graph doesn't go out to -12. So picking -2 was a bad choice. Does that mean the problem's over and I give up? No. That means I keep going and hopefully -1 isn't a bad choice, and then I can get some friendlier points that I can graph. Right now, trying to graph -2, 12 is just not going to look right for me. So let's just keep going and see what happens. All right. F of -1, I'm plugging in -1 for every x, so 4 times parentheses -1 minus 4. 4 times parentheses -1 is -4. -4 minus 4 is -8. So now when I plug in -1, I get out -8. Now I do have a point that I can graph. So hopefully we're on the right track that we were once off of our graph, and now we're back on it. So let's keep going and see if the numbers are friendly enough. F of 0 means replace every x with parentheses 0. So 4 times 0 minus 4. PEMDAS says 4 times 0 is 0. 0 minus 4 is -4. When I plugged in 0, I got out -4, easily graphable. F of 1. 4 times parentheses 1 minus 4 is 4 times 1. 4 minus 4 is 0. 4 times 1 is 4. 4 minus 4 is 0. Bada bing. That gives me the point 1, 0. 2. F of 2 equals 4 times 2 minus 4. 8 is 4 times 2. 8 minus 4 is 4. So when I plug in 2, I got 4. When I plug in 2, I got 4. So even though one of these didn't work, 4 others did. And that's why I choose 5 points every single time that I've done this so far, is because you may have one that won't work. That's okay. We just won't graph it. Am I wrong? No. We just won't graph it because we can't. So I'm going to graph -1, -8, because that will barely fit. This has me starting out at 0, 0, go left 1, go down 8, -1, -8. 0, -4 has me starting out at 0, 0. Don't move, go down 4. 1, let me put a blue dot there so we know what's what. 1, 0 has me starting at 0, 0, going right 1, don't move. So that's 1, 0, right 1, don't move. And last but not least, we have 2, 4. And if you're wondering, what's a 2, 4? For chewing. You go right 2, you go up 4, you go right 2, you go up 4, and there you have it. Now, when you graph a function, you're going to get whatever dots based on the points that you chose initially. I got 4 dots. So what am I done? Or do I just like walk away and say I'm done the problem? No. Here's the thing. These are the dots I got because these are the x's I chose. If I were to choose 3, I would be able to squeeze another dot right there at 3, 8. But I didn't. So what we're going to do to graph this is we're supposed to assume that all of these points are represented. So I'm pulling up a line. That's the thing you're seeing on the left side. And we're going to connect these dots. Again, when you graph a function, right, you are going to take all of the dots and connect them, the denots. Now, this is wrong. Me connecting only the dots that I have is wrong. And if you're wondering, like, why? Those are the 4 points you got. Yes, but again, those are the 4 points I got because those are the 4 points I chose. If I chose 3, there'd be another dot up there. So we have to include all possible values. So this line is going to keep going forever and ever and ever. So make sure your line covers the entire coordinate plane. If you're doing this on paper, make sure you use a ruler, and that'll help you figure that out too. I'm going to put arrowheads because this says, look, if this coordinate plane was even bigger than it already is, I'd have dots way up here and dots way down there. But that's how you graph a function. You pick whatever x values you need to do or you want. Okay, you choose what your f of x is based off of the x's that you do. You do whatever math. That gives you points. Oh, well, none of them or one of them didn't work. Then one of them didn't work, but 4 of them did. And 4 points is more than enough to make a nice straight line. So there you have it. That's how you graph a function. Thanks for watching.